Greetings and welcome. My name is Brian Waddy. I'm here to teach you how to use information about congruent triangles to prove further information about their corresponding parts. And so the theorem we're going to use is abbreviated CPC-TC for corresponding parts of congruent triangles are congruent. So our first objective, notice our objective is going to be different than previously. All right, so here for example 1, where previously we might have, our goal or end goal might have been to prove two triangles were congruent. This time what we're going to do is we want to prove two pieces of information, whether angles or sides happen to be congruent, or find the measures of an angle or something like that. And in order to achieve our goal, we're going to have to take the long way around. It'll turn out that we won't have a means of relating those two things just yet. What we will first do is prove the two triangles themselves are congruent, and then, using the fact that they're congruent, conclude that their corresponding parts, their related pieces, must also be the same. So here we go. Here we've got some given information, and when writing a proof, we're going to do some two-column proofs today. So instead of just saying or claiming that something is true, when we write our statements, we're going to justify our statements with mathematical reasoning. We don't just assume that anything anyone ever says is true. That's probably a bad idea, really bad life advice. So for every mathematical statement we give, we're going to give a reason as to why it is true. And the reasons we can use are either given information, previously proven theorems or postulates, definitions we can use, any of that information. So when you come to a problem like this, it is expecting you to know a decent amount of previous knowledge. You're going to have to come to the table with your box of tools of all of your theorems and postulates and definitions, and be ready to fill those in as justification for each step. So let's jump right in here. So the first thing that we can do is a statement of things that are true. Let's label our given information. So I'm going to say that AB, segment AB is parallel. That's what this kind of double bar symbol is, to CD. And the way that we would label that is AB is parallel to CD with a single arrow for both of those. And the reason that is true is that was given information. All right, given information. Let's see, I'm trying to resize my cursor here. Yikes. It's a little bit better. Even better. So given information. So I label it on my picture, I write this statement down here, and I give the reason why it's true. All right, the other fact that we knew that was given to us was that BC was parallel to DA. All right, and the reason that is true is given, and let's label that information on the graph as well. And I don't want to label this with a single arrow because that would be suggesting that this segment is parallel to that segment. So I'm going to label it with a double arrow, suggesting that any two segments or lines that I label that have the double arrows will be parallel to one another. So with this information, now I've got a variety of ways that I can go. Now let's look at what our end goal is, because sometimes we might be able to just conclude that to begin with. So that we want to prove AB is congruent to CD. So I want to prove AB is congruent to CD. And currently I don't have any way of proving that. Just because they're parallel doesn't mean they're congruent, right? CD could have been longer, could have been like a trapezoid or something. Just because they are parallel does not mean they are congruent. But I do have a bunch of other information here that I might be able to use. I've got two triangles here and a parallelogram, but we're not in the chapter about proving anything about parallelograms. So I'm assuming this problem's about triangles. So let's see if we can first prove these two triangles are congruent. So in order to do that, let's just start looking at what information we have. So let's, I see that we could label this congruent to itself. So I'm going to say that BD is congruent. Remember, it's like the little equal sign with a squiggle above it, is congruent to BD. And the reason that's true is the reflexive property. Reflexive property of congruence, we could just say reflexive. That'll be sufficient amount of information for us to go off of. Let's see, I'm going to need some more space here. So the reflexive property states that that's true. Do I have enough information to prove these triangles are congruent? No, not yet. Remember, the current theorems I know to prove triangles congruent are side, side, side. If I could prove 3 corresponding sides to 3 corresponding sides, I could do side, angle, side, angle, side, angle, and angle, angle, side. So those are currently the 4 techniques or ways I have to prove triangles congruent. Right now, I've got a side congruent to a side, which doesn't really narrow down our path for us. Now, the fact that these are parallel to each other, you might remember some of your properties regarding parallel lines cut by a transversal. You can see we've got these 2 parallel lines cut by this transversal, and I think we can conclude that, let's see, I'll use this color here, that this angle is congruent to this angle. And I can't just refer to that as angle B, because there's actually 3 different angles here. I could refer to, right, this could have been what I meant. I could have meant this angle, or I could have meant the entire angle. Theoretically, I also could have been any sort of crazy angle besides that. So I'm going to need to be specific, right? So in order to do that, let's label that angle ABD, where the vertex of the angle is the middle letter of the 2 sides that I'm referring to. So I'm going to say angle ABD is congruent to angle, and let's see, we might as well try to follow the same pattern. So notice I started out on the outside point of the triangle and then went in. So let's start on the outside point here and go in towards D. So I'll call this CDB. And you could have labeled this angle kind of the reverse order, DBA and BDC, and that would have been fine. So there's actually multiple ways we could be talking about the same problem. Now, I've concluded that these are congruent. You might agree with me they're congruent, but we need to give a reason as to why they're congruent. So one of the ways we can do that is because these were 2 parallel lines cut by a transversal, they were on opposite sides of the transversal, and they were inside the 2 parallel lines, right? They're on the interior of the parallel lines. You might remember that these are alternate interior angles. And the alternate, let's see, alt-int angles theorem. Alternate interior angles theorem, which from now on I'll abbreviate as alternate interior angles theorem, AIT, maybe, I don't know, sure. Alternate interior angles theorem says that alternated interior angles that are between 2 parallel lines cut by a transversal are congruent. So we just proved that. So now I've got 2 corresponding angles and a corresponding side are congruent to one another. So I've got angle side or angle side. I'm thinking it could be one of these, but theoretically it could be, we've eliminated this as our strategy so far. So that's not what I'm trying to do. So if I could prove another side or another angle, I think we'll be good as far as proving the triangle's congruent. So let's see, as far as these parallel lines cut by a transversal, I think we can conclude similarly that these 2 angles, and notice I'm doing the double arc, that these 2 angles are congruent, not congruent to the first pair. And let's label these correctly. Let's label this CBD, so angle, well actually I started with this triangle first last time, maybe we should do that. We'll do ADB is congruent to angle, let's see, so I started from the outside point, so I should do CBD this time. And the reason is alternate interior angles theorem. So I believe we have enough information. I've got an angle, a side, and an angle. Now, I've got to figure out, I've got 2 angles and a side. Which of these 2 will prove it for me? And one of the ways you can think that is as you're moving around the triangle, so to speak, look at the sequence that you come across. So I've got, I'd hit an angle first, then a side, and then an angle. The side is the included or the adjacent, the in-between side between those 2 angles. So if the side's in between the angles, it must be angle, side, angle that I'm working with. So let's conclude that these two triangles are congruent. And I gotta label this information in the correct order. And since I've been careful with both of these arrangements, I could actually talk about triangle ADB and CDB, or ADB and CBD. Doesn't matter, as long as the sequence that I give is the correct sequence. Okay, so let's see. Let's talk about triangle ABD. I happen to like that. Seems almost alphabetic. So triangle ADB is going to be congruent. Now I have to match this up. C, I hit my single arc angle first. So C to D, and then to B. Okay. So I've proven the triangles are congruent using which reason? Using angle side angle. So let's see. Actually, I don't know if the folks online can even see this yet. My apologies. Angle side angle theorem, right? So ASA is sufficient for that proof. Now I've proven triangles are congruent. That's really good news for us. Hooray, right? But that's not what I set out to prove. What I wanted to prove was that AB is congruent to CD. And notice that AB and CD, let's see, I can't label those with single marks, can I? They're corresponding, AB and CD are at least corresponding in the arrangement, right? A and B, they're kind of on the outside, and C and B are on the outside in the arrangement here. So they're corresponding in that regard, and they're corresponding as far as the images are concerned, that this and this are going to be congruent to one another. And so I can conclude that because these triangles are congruent, that their corresponding sides must be congruent. So I'm going to say that AB is congruent to CB. Is that correct? Let's see. That is not what I said. What did I do wrong here, folks? Let's see, I did ABD to CDB. CDB. And I'm trying to prove AB. I labeled this wrong. That's pretty great. It's pretty great. If I was teaching this in front of live students, hopefully you guys would have corrected my error. So let's see. So here we go. ABD. Man, and I was talking so much about the significance of that sequence, wasn't I? So AB and CD, you can see that they're still corresponding. There we go. That's crazy sauce. My apologies. So AB is congruent to CB. AB is congruent to rather CD. There we go. And so I've got a couple little errors to fix here. That's all right. That's quite all right. And the reason that's true, why is that true? Well, I know that the triangles were congruent, and therefore their corresponding parts are going to be congruent. So we're going to call that CPCTC. Corresponding parts of congruent triangles are congruent. So there we go. That's our example one. Let's take a look at another example. Okay, so we're once again, now this so far mentions nothing about triangles or sides, so this is actually going to be quite the interesting problem. So we're going to do the same setup. We're going to have statements and reason. I'll just write statement singular and reason. Usually my statements are longer, so I try to make this side of the column, this column wider than that one. So let's see. Let's label what we got. So it says A is midpoint of MT, and I've got A is midpoint of SR. Okay. The reason those are true, given, of course, given. And I actually don't have a good way of labeling that. We didn't have like a little tick mark notation for that. So that's okay. I'm just going to label that and kind of keep that in mind. Now the goal, my outcome that I'm trying to aim for is proving that this is parallel to that. Now proving lines are parallel, you might recall, required saying something about their angles. All right, saying something about their angles. So if I could conclude something about these two angles or these two angles and prove those congruent, then I might be able to prove the lines are parallel. So I'm going to aim for either of those, and it probably doesn't matter in this case. Yet I don't have a way to say those angles are congruent, but perhaps, what if I could prove these triangles were congruent first? Let's aim for that. So here's the multiple steps. Prove the triangles are congruent. Prove that these angles are congruent, and then prove the lines are parallel. So we've kind of got like three massive movements of this proof that are going on. So if I'm going to try to prove these triangles congruent, let's try to figure that out first. Let's see. Let's start labeling information I know. I see this is jumping out at me right here. I like this right here. And I can't refer to this just as angle A because there's quite a variety of angles that I could be referring to that have a vertex at A. So let's call this angle SAM is congruent, so SAM is congruent to angle, and it looks like RAT. RAT. I don't think that it's the TAR version based on the way that it's been drawn. So Sam is congruent to rat. I apologize if any students are named Sam. And the reason that's true is the reflexive property of congruence, right? So I know that much. I think we could also prove that MA is congruent to AT. Now the reason that's going to be true, so let's write that down. Let's not get ahead of ourselves. So I'm going to say MA, the segment, is congruent to, I'll say TA, that's probably mata. The reason that's true is def of midpoint. Okay? Definition of midpoint. If this is the midpoint of the segment MT, then it divides the segment into two congruent parts. Definition of midpoint. So here's a case where we don't have a theorem or a postulate. We just had to know this definition. And that's what we ended up doing. So definition of midpoint proves that, and I think you guys can see that similarly, I'll be able to conclude this, that SA, segment SA, is congruent to segment RA. Right? And for the same reason, def of MP. Right? So mathematicians, as efficiently lazy people, we like to get further and further with our abbreviations, right? Even just the fact that we're using symbols rather than writing out the word angle or congruent or segment TA. Yeah, we're comfortable with some amount of abbreviation. Okay, so I've got a variety of information here. I think we can prove these two triangles are congruent. And notice that as I pay attention to the flow, as I move around the triangle, I hit a side, I hit an angle, and a side. Right? Even if I try to start at the angle, side, I don't know this next side. And that, by the way, is not a theorem that proves triangles are congruent anyway. But it looks as though I could prove these triangles are congruent. Let's see, I think my internet folks missed out here again. So I'm going to say, let's say Sam and rat, just because we can. So triangle Sam is congruent to triangle rat. And the reason that's true was because I had side, angle, side, right? Two sides and their included angle, right? The angle was in between those two things. So side, angle, side is what we have. So I've proven triangles congruent, but that has not yet proven what I set out to do. That did not conclude my mission. But because these triangles are congruent, you might agree that we could say that this angle and this angle are congruent. And that's going to help us out. You also could have chosen the alternate route, proving that these two angles are congruent. I'm just going to go with S and R here. So I'm going to say angle S is congruent to angle R. And I don't need the three-letter name for those because that's really the only significant angle there, unless I was considering kind of the obtuse version of that. So angle S is congruent to angle R. The reason that's true, I don't know that the lines are parallel yet. The reason I know that's true is because I know that the triangles are congruent. and that corresponding parts of congruent triangles are congruent, right? Okay, there we go. So now if I know that those angles are congruent to one another, now I believe, my friends, I think I can conclude that these line segments are parallel. MS is going to be parallel to TR. MS parallel to TR. And the reason that's true, you might have to recall back maybe a chapter or so. Now angle S and R were alternate interior angles. They're interior as an inside between these two lines that may or may not be parallel. And they were on alternating sides of the transversal that cut between those two lines. And the alternate interior angles converse, AIC, right, proves that if alternate interior angles converse starts with congruent angles that are alternate interior and concludes with lines being parallel. The alternate interior angles theorem would have started with parallel lines proving the angles were congruent. So there we go. So there we were just able to prove these two triangles were congruent first, and then using the fact that they were congruent, conclude something about their related parts, and then I was actually even able to take this one step further. Here, let's see. Let's do one more example. This one's beast mode right here. Here's another example. All right, this is actually going to require you to think outside the box, or perhaps outside the triangle, depending on how you think about it. Might be able to hear my kids screaming a little bit upstairs, but that's okay. I assure you they're fine, and they do have parental observation occurring. So let's see. Let's do the two-column proof again. Statement and reason. And this, there is actually a lot of information that you will be able to write down about this. However, not all of it's going to be helpful in me leading to my conclusion that I want. So what you might end up doing first is you might kind of explore out in a couple of dead-end patterns with this proof, and that's perfectly okay. And then eventually you might go back and refine your proof to being just kind of the bare minimum, the shortest path, because mathematicians are not just looking for the most accurate answer, but sometimes they're also looking for the most elegant answer. Just what's the easiest, the flow that makes sense, something that's elegant as well. So let's start with the given information. Angle 1 is congruent to angle 2. Oh, I'm writing in the wrong color. I know that's going to annoy someone. I'm pretty sure. So I'll change that. Angle 1 is congruent to angle 2. The reason that's true, given, of course. And it looks like we've got that labeled here, angle 1 and angle 2. Actually, I'm already switching colors on you again. You guys are so annoyed, aren't you? And notice that they offset these two arcs so that you can see that these are talking about the two smaller arcs and not the one larger arc. The other thing I know is that angle 3 is congruent to angle 4. The reason that is true is also given. And that's double arc, double arc. And okay, and I'm trying to prove something about this little triangle. Let me actually draw these the same way. BCE, so BCE, this triangle, I'm trying to prove something congruent to this triangle. Now, I might be able to try or attempt a proof regarding these two triangles, but we'll actually see that that's not going to help us. Or unless I'd end up getting to a path where I have to really communicate about these two angles being added together, and that's going to be a little bit difficult. Or, I mean, it's doable, but it's just the long way around. So instead, because angle 2 and 4 are on the same big triangle, I'm going to let's talk about this big triangle and big triangle, like so. Okay, so let's talk about those two triangles. If I can prove these two triangles are congruent, I might be able to conclude something about some of their corresponding sides or angles, and then I might have enough information when talking about these two tiny, tiny triangles. Okay, so right now, regarding these two large triangles, I have an angle and an angle. Wouldn't it be convenient if I had a corresponding side that I could relate to one another? And I believe we do. It looks like segment CA, the big all the way across segment, is going to be congruent to itself. And you might think, well, that's okay, I guess, right? So that CA is congruent to itself. The reason that's true is the reflexive property of congruence. So that's the reason that is true. Reflexive property of congruence. And here, now that I have that, I've got, notice, an angle, a side, and an angle. So I think I can conclude that these two larger triangles, wow, my kids, at least those screams you might be hearing are happy screams. That's a good thing. That's okay. They're running around like crazy. It's great. So here we've got triangle. Doesn't matter which order that I do the letters. Let's just do CDA. Is congruent to triangle, and I'm going to have to start at the matching congruent angle, right? So these correspond. CBA. And the reason that those two triangles, those mondo macro triangles, are congruent was we had an angle, we had a side, and an angle. The side was in between those two angles. So angle, side, angle congruence. I don't actually recall if that's a postulator theorem, but it doesn't matter. Angle, side, angle. So now that I've proven that these two are congruent, how is that going to help me talk about these two little guys? Well, for the little guys, I currently know an angle and an angle. I could talk about the big angle here, but that big angle doesn't fully relate to the little one. I don't think that's going to help us. Maybe this segment and this segment will be the most helpful. So let's say that. Let's say that segment CD is congruent to segment CB. And notice that they correspond with the positions there. They correspond with the picture up here. This is wonderful stuff. Also, I think my online folks can't see that. So CD is congruent to CB. The reason that's true, well, I already know that their triangles are congruent, so their parts are going to be congruent using corresponding parts of congruent triangles are congruent, right? I think you guys agree. And now that is going to help us. So I've got, let's see, this is congruent to that. I've got an angle and an angle and a side and a side. It looks like the other piece of information I could go off of is this side being congruent to itself. CE congruent to itself. Now, it would be convenient if I knew that one of these was a right angle, but I can't assume that based off of the current drawing. Because that would have been an angle. Actually, that I would end up having to prove another angle first as well, unless you use a later theorem that you don't yet know. So we won't talk about it. But CE is congruent to itself. CE is congruent to CE. And hopefully that's obvious why that's true. It's the same as up here. The reflexive property of congruence, like so. And lastly, now that I have three pieces of information that are sufficient to prove these triangles congruent, I believe I can conclude that BCE will be congruent to DCE. So BCE to triangle DCE. And the reason that's true is not CPCTC. Okay, let's take a look at what we know. I have a side, an angle, and a side. Side, angle, side. Side, angle, side. So side, angle, side is the reason that that will be congruent. And in order to have proven that, what I had to do along the way was prove that two other triangles were congruent, and then use the fact that their corresponding parts were also congruent. Well, thank you so much for watching, friends. I hope you have a great day.